Human Environmental Impact, How We Affect Earth by Ava Sawyer. Chapter 1. Have humans impacted Earth? Ever since humans developed agriculture and built cities, they have impacted Earth in some way. It's estimated that 80% of Earth's land surface has been affected by human activities. Not only have people impacted Earth's land, but they have also impacted its atmosphere, biosphere, and hydrosphere. The atmosphere is the mixture of gases that surround Earth. The biosphere is the part of Earth in which life can exist. And the hydrosphere is the part of Earth including bodies of water and water vapor in the atmosphere. The development and expansion of cities has displaced animals and eliminated their habitats. Some human activities have been positive for the environment. However, many results from human activities have been negative. Humans heavily rely on natural resources. They plow up natural vegetation and chop down forests. They send pollution into the air and dump chemicals into water resources. People may not realize how their actions can affect the environment. Natural resource, something in nature that is useful to people, such as coal and trees. Forests are often burned or cut down in order to make room for the development of cities. Chapter 2. Human Impacts. Garbage disposal. Garbage is a major human-caused problem. Landfills are huge garbage dumps that can take over large areas of Earth's land. Some of the materials in these dumps take hundreds or thousands of years to decompose and break down. Objects such as plastics never completely decompose. Some thrown-out materials contain toxic, which means poisonous, chemicals. When those chemicals leak into the land, they pollute both the soil and the groundwater. Garbage piles up in a countryside open landfill. Decompose means to rot or decay. Landfills are also a problem because of methane gas. When materials like food, tree branches, and plants are covered up in a landfill, they break down in an anaerobic way. This causes the formation of methane gas, which is a greenhouse gas. It traps 21 times more heat in the atmosphere than carbon dioxide does. Anaerobic means not using oxygen. Greenhouse gas, gases in a planet's atmosphere that trap heat energy from the sun. A gigantic hill of garbage is placed near Moscow, Russia. Garbage isn't only dumped on land. It is also dumped in the ocean, whether on purpose or by accident. Much of the garbage that ends up in the ocean is made of plastics. Sunlight breaks down plastic into smaller pieces. However, the pieces don't disappear altogether. Garbage floats along ocean currents and then gathers together in big patches. One of the world's most famous patches is called the Great Pacific Garbage Patch. It's located in the Pacific Ocean between Japan and California. There are actually two distinct patches. One is between Japan and Hawaii. The other is between Hawaii and California. The Great Pacific Garbage Patch is estimated to be twice the size of Texas. A small portion of Earth's garbage floats on the top of the ocean. The rest of the pieces, 4 billion or more, sink to the deep sea. Some of this garbage includes large objects such as water bottles, electronics, toys, and toothbrushes. They float across the oceans from beaches around the world. Sometimes they are thrown off ships in the ocean. Garbage patches. Garbage patches are found in every single ocean and sea around the world. Experts estimate that there are 5.25 trillion pieces of plastic in the oceans. Some of the garbage is very small, about the size of grains of rice. The sun has already broken those pieces down into smaller particles. Plastic in the ocean is extremely dangerous for animals that live there. They get tangled in it and mistake it for food. The presence of plastics can destroy marine life. Plastic and metal containers sit on the ocean floor among sea life. Forest depletion. Forests are hugely important to the survival of our planet. They keep the carbon dioxide and oxygen in our atmosphere balanced. The tropical rainforests are of particular importance. These are often called Earth's lungs because they provide the atmosphere with so much oxygen. Fact: Earth once had more than 8 million square miles, which is 21 million square kilometers, of tropical rainforest. But humans have cleared much of this area. Now less than half remains. Forests are cut down for many reasons, but it takes many years for them to fully grow back to what they once were. For many years, the wood from forests has been used as a fuel and a building material. Sometimes forests are cleared to make room for farmland or to raise cattle. These forests are renewable because they can be replanted. However, people are using up this resource more quickly than it can be replaced. The trees in some forests take hundreds of years to fully grow. Renewable means restored or replaced by natural processes. Rainforests near the Malaysia-Kalimantan border. Chapter 3: Non-renewable resources. Human beings rely on Earth's resources to survive and build. Some of these resources are renewable, such as wind and sunlight. They can't be used up. Others, such as soil and forests, can be replaced over time. But other resources are non-renewable. That means there is a fixed amount. Non-renewable sources could someday run out. Non-renewable resources include fossil fuels, such as coal, natural gas, and oil, as well as minerals. Non-renewable means not able to be restored or replaced. Fossil fuel is natural fuel formed from the remains of plants and animals. Coal, oil, and natural gas are fossil fuels. Pump jacks extract oil from a Kern County, California oil field. Fossil fuels. Most of the world's energy comes from coal, natural gas, and oil. We process and use these in many different ways. These energy sources power everything from our cars to the furnaces in our homes. But fossil fuels take millions of years to form. Once they are gone, they cannot be replaced. The burning of fossil fuels also causes pollution and damages the environment. Retrieving fossil fuels can have negative effects as well. Mining often has a lasting impact on the environment. Surface mining involves stripping away the plant life, soil, and rock. Mining also creates huge amounts of waste rock. Sometimes the waste is dumped into old work sites that become empty pits. These pits often fill with water, forming lakes. The poisonous waste of minerals such as copper and uranium sometimes leaks into the soil or ends up in these lakes. Coal. Most coal is burned to produce electricity, but it can also be processed into both a liquid and a gas. Coal gas powered the first gas lighting systems more than 200 years ago. Liquid coal can be used as a fuel for vehicles. Another important product from coal is a solid gray substance called coke. It is made by baking coal at high temperatures. Coke is used as a fuel or in the process of making steel. A power plant pumps smoke into the air as it burns coal. Oil and natural gas. Oil, or petroleum, is a thick, black, energy-rich liquid. Petroleum is also sometimes called crude oil. It is a mixture of many substances. To use it, the different materials within crude oil must be separated. Most of the world's oil is used to make fuels. It is also used to make products such as plastics, motor oil, wax, and pavement for roads. Natural gas occurs naturally in a gas form. It consists mostly of a gas called methane. It also contains propane and butane gases. Natural gas powers furnaces, stoves, and other appliances. Compressed natural gas can be used to power motor vehicles. Fossil fuels won't last forever. However, the use of renewable sources, such as solar energy, geothermal energy, and wind energy, are on the rise. All of these sources provide energy while causing less damage to the environment. Fact: one day, mining companies may have to dig and drill deeper and under more difficult conditions to reach fossil fuels. At the rate we now use fossil fuels, some scientists estimate the world's reserves will only last 40 to 70 more years. Crude oil is poured from a bucket. Chapter 4: Alternative Energy Sources. Solar energy. Energy from the sun is called solar power. People collect this power in a number of ways. Solar panels soak up sunlight and convert it into electricity. Solar thermal plants use many large mirrors to focus sunlight onto a small area. This focused sunlight creates tremendous heat. This is then used to turn water into steam that powers electricity-generating turbines. The sun's heat can also be used to warm water for homes, businesses, or swimming pools. Water is pumped through pipes in glass panels called solar thermal collectors. Turbine is a machine with blades that can be turned by wind or a moving fluid such as steam or water. Solar fields are placed in wide open areas that receive a lot of sunlight. The best part about solar energy is that sunlight is free. However, solar panels are not. Building solar power stations is very expensive. The main drawback of solar power is that it's not always available. It requires an area that receives a lot of sunlight. Solar plants don't produce at night or when clouds hide the sun. Storing solar energy can also be difficult. Some people put solar panels on their homes or property to save on energy bills. Geothermal energy. The heat within Earth is a powerful energy source. It is called geothermal energy. The temperature of the Earth gets hotter deep underground. The deeper the spot, the hotter it gets. Geothermal power can be collected several ways. One way is by drilling wells into cracks in rocks where the groundwater is hot. The hot water or steam either flows up or is pumped up. It then turns turbines that generate electricity. Another way to use this power is by pumping water down to hot rocks in the earth. The water turns to steam, which comes up through pipes and turns turbines. The turbines then drive electric generators. And there is a diagram of a geothermal power plant. Fact: some homes use geothermal energy for heating. A liquid is pumped through pipes that run deep underground. The liquid is heated and pumped back to the surface. The heat it carries radiates into the building. There is a geothermal power plant in Iceland. Wind energy. Wind is another source of energy. For centuries, people have used windmills to harness the energy of wind. Wind pushes the propeller-like blades on these towers. The energy from this motion can be used to pump water, grind grain, or power a generator to produce electricity. Electricity generating windmills are called wind turbines or wind generators. Wind power is the fastest growing energy source in the world. It is free and creates no waste. Wind energy is renewable because wind keeps blowing. But wind is not always reliable. It often works best alongside other energy sources. Some people have criticized wind farms for damaging wildlife, including bats and migratory birds. Fact: wind is a result of the way the sun unevenly heats Earth. Air moves around the world because of the unequal pressure caused by this uneven warming. The moving air is wind. A wind turbine farm in the Netherlands. Nuclear energy. Nuclear energy is made by splitting the atoms of the element uranium. This is called fission. To get this energy source, workers at nuclear power plants shoot neutrons into uranium atoms. The atoms break apart, releasing energy and more neutrons. Those neutrons hit other atoms which also break apart. This is called a chain reaction. Nuclear power makes about 11% of the world's energy. It makes a great deal of energy from a very small amount of fuel. Nuclear power costs about the same as coal power, but it generates less air pollution. However, nuclear waste is radioactive and very dangerous. It takes special care and handling. The radioactive waste has to be sealed and buried for many centuries before the radioactivity fades. Fission is the splitting apart of the nucleus to create large amounts of energy. Radioactive, having to do with materials that give off potentially harmful invisible rays or particles. And there is a diagram showing the process of nuclear fission. Hydropower. Water power is another renewable resource. In fact, it's the most abundant. Some power is harnessed from flowing water to create electricity. Nearly 10% of power plants in the United States run on hydropower. How hydropower works. Rivers are a natural source of flowing water. The moving water contains huge amounts of kinetic energy, or the energy of motion. Hydroelectric power plants use this energy. The power plants are built across rivers, and the water flows through turbines. The turbines spin and generate electricity. Most hydropower stations rely on dams. They control a river's flow. Dams can create an area of water upstream called a reservoir. The reservoir serves as a large storage of controllable potential energy. As the dam allows the stored water to flow downhill, pipes or tunnels channel the water to turbines. Then the water exits out the other side of the dam. Chapter 5. How can humans help? We can all do our part to limit our use of Earth's resources. In the modern world, humans have become more aware of their impact on the environment. A greater effort to reduce our impact on Earth has been seen across the globe. Picking up trash is one way to help clean up the environment. Protecting and conserving water. Humans have realized that dumping waste of any kind into water destroys that water source. Government agencies in the United States have formed over the last 100 years to control and monitor waste. They build treatment plants, clean wastewater, and prohibit industries and factories from dumping chemicals into rivers and streams. The factories' emissions into the atmosphere are also monitored. Many cities have tried to reduce the amount of waste that doesn't break down naturally, such as glass and plastics. People are encouraged, and often required, to recycle, reuse, and reduce their usage. Landfills. Cities have also tried to turn their landfills into power sources. A landfill's methane is useful if it is captured. It can be converted into a power source for electric power plants. One of the landfills used by the city of Los Angeles uses its methane gas to provide electricity to 70,000 homes. Pollutants dumped into a water source can quickly spread throughout a lake, river, or ocean. You can also make a difference by conserving water. By reducing water usage, we help preserve groundwater supplies. We also use less energy, which is needed to purify and pump the water into our homes. A few simple practices can make a difference. For example, drink tap water. Bottled water may be convenient, but all that plastic adds up. Make sure your dishwasher is full before you run it. The same goes for your washing machine. Wait for a full load of clothes before you turn it on. Also, use cold water. Most of the time, it cleans just as well as hot water and it saves energy. Try not to waste water by overwatering lawns. Water early in the morning or in the evening. Some people conserve water by using rain barrels. These barrels collect rainwater that falls off houses or other buildings. The collected water can be used to water grass or gardens. Water from rain barrels can be reused for many things, such as watering gardens. Conserving energy. Humans use a lot of energy, but there are some simple steps we can take to reduce the amount we use. Keep lights off when you're not using them. Close the heating and cooling vents in rooms that you rarely use. If you can, hang your laundry outside to dry. Also, set your dishwasher to air dry. When you cook on the stove, be sure to use the right size burner for the job. A small pot on a large burner wastes energy. Also, if you have one, use a toaster oven to cook small meals. It uses less energy than a big oven. These may seem like little things, but they can add up. While there are still many ways that humans can improve their activities, a conscious effort to change our impact on Earth is a good start. By doing our part, we can each help to preserve the future of our natural resources and environment.